Hi guys, these are the 2015 Year 9 NAPLAN Numeracy Non-Calculator work solutions. Hopefully they are there to help you work out not just if you got answers right or wrong, but also how I got the answers that I did. So let's get going. The table shows a pattern. The top and bottom numbers are connected by a rule. What is the top number when the bottom number is 27? So what we're trying to do is work out how do we go from 1 to 3, from 2 to 6, from 3 to 9. Now, when people do this, they go, oh, well, I'm adding 2, adding 4, adding 6, adding 8. That's certainly a way of doing it, but that doesn't necessarily help us. We're looking for a times rule. And just zooming in a little bit to give myself some space. If I take each of the top numbers and multiply them by 3, I in fact get the bottom number. So the rule is take the top number and times by 3. This, on the other situation, if we're doing it backwards, we would therefore divide that by 3. 9, 18, 27 will give me the correct answer. So 9 is my missing number, right? And generally speaking, we're looking for a multiplication rule. Luca has a $10 voucher to spend on games for his smartphone. He bought 3 games at $1.99 each. Which expression shows how much money he has left to spend? So how much he's got over. So what does he say? He starts with 10 and he's bought 3 games at $1.99 each. So we're going to take away 3 times $1.99. So it can't be this first one here. Could it be the second one? Maybe. Could it be the third one? No. Now I'm going to say for a start it's actually this one here. Right? Because we've got 10 minus 3 lots of $1.99. In this situation here, what's actually happening is they're doing $10, they're taking away one of the games, but they're actually adding on 2 of the other games. So they're not actually subtracting the money, so that's actually not right. Here, what's happening is they're taking away one of the games and then multiplying that by 3. That's not right. What we want to do is work out 3 lots of the game and subtract it by 10. By putting it in brackets first just tells me we're going to do this bit first. The spinner is spun twice. The 2 numbers that the arrow lands on are added. Which of these totals is most likely to occur? Now, in that situation, what we're going to do is we actually do a table because it's looking for 2 numbers, and we've got 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So there are 2 numbers and there are 2 outcomes. So what we then do is, because they are added, we're going to then add all of these values together. So it's going to give me 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9. Where are we now? 4 plus 1 is 5, 6, 7, 8, 9, and 10. 5 and 1 is 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, and 12. So all I'm doing there is taking each of these horizontal numbers there, or each of the numbers in a column, multiplying it by the row and putting the answer. So 1 plus 1, sorry, adding them, 1 plus 1 is 2. So this one here, if I was doing 4 and 4, then we would know that they would in fact give me 8. And so it goes on. Now, because it wants to know which of the ones is most likely to occur, what are we looking for? Well, obviously in this situation, the number that appears the most. And as it turns out, it is 1, 2, 3, 4, 5, 6. There are 6 7s. That is the one that's most likely to appear. And so 7 is my correct answer there. Some tiles are missing from this pattern of tiles. When complete, the pattern has 2 lines of symmetry. Which of these could be the missing part of the pattern? So 2 lines of symmetry means that when we fold this shape in 2 different ways, it is going to look exactly the same. All right, so I'm suggesting that this one here would have to be a white one to give me a line of symmetry down the middle here. And probably we're looking for a line of symmetry across the middle there. So actually we're looking for a shape that's going to look something like that. And so where are we going to do? See, interesting one. Up, there we go. So it's got to be this one here. Now again, the only way of doing that is just by mentally looking at it and sort of slotting it in to try and make sure it's the one that actually fits. So again, this one here is going to be my correct answer because the other ones aren't going to actually fit with the right space because we need 2 here and 1 in this bottom corner, which means we need 2 here and 1 in this bottom corner, which basically gives me this one here. The graph shows the history of the men's high jump world record. By about how many centimeters did the world record increase between 1970 and 1985. So we're going to look for the world record at 1970, which is this one here, and 1985, which is this one here, and we're going to sort of approximate the answers. Well, this here is obviously smack on the line at 2.4. This is roughly, let's say, 2.28, and again, that's a value judgment. I'm looking for that, and so we're looking for the difference in that, and that was approximately 12. So we're looking for the number that's closest to 12, and in this situation, I would suggest that that would give me 11. Brad was trying to draw a net of a rectangular prism. Now, a net is basically a shape that when you put it flat would create a 3D shape when you put it all together. He drew one face of the prism incorrectly. Which face did he draw incorrectly to get the net of a rectangular prism? Okay, so as far as I am concerned, it is shape D. Now, it took a long time for me to think about it. Why is it shape D? Well, when we fold this thing together, we have to make sure that sides go together. So this side length here is going to join this side length here, so they have to be the same length. This side length here would join this side length here, has to be the same length. This side length I'm colouring in now would join with this side length, has to be the same length. This side here would have to join that side there, and what do you notice? That's actually quite short. That there is quite long, and in which case they wouldn't join together, all right? Not without this one here sticking out. So as far as I'm concerned, it's D. All right, so 5 times 2 cubed, that's 5 times 2 times 2 times 2. So remember, when you have a floaty number, that's the same as writing 2 times 2 times 2. Why do we write it 3 times? Because of that floaty 3. If I had 3 to the floaty 4, I'd do 3 times 3 times 3 times 3. Those are indices, right? So now we're going to do this. And what's that going to give me? Well, 5 times 2 is 10. I'm going to times that by 2, which gives me 20, and times it by 2 again, which gives me 40. And again, the way you do this is really up to you. Some people do 5 times 2 times 2 times 2, and what they do is they say, well, 5 times 2 is 10. They'll work out this 2 times 2, which is 4, and multiply them together, which gives me 40. Right, so the great thing about multiplication is you can sort of split it up and do it in that way. Okay, so we know one smiley face is 6. What is the value of a question mark? What is the value of a star? So we know that 6 times a star is equal to a star, a star, a star plus a smiley face. So I'm going to put 6 in there. Now, because we already know algebra, we can work this out. So what we've got now is 6, and let's call a star x, is equal to 3 x's, because that's 3 stars, plus 6. Now that we have this in an equation, what do we need to do? We get the x's on the same side, so I'm going to subtract 3x from both sides, right, so that I've only got x's on one side. That obviously means that that's going to disappear to give me 3x is equal to 6. So x becomes equal to 2, because we're going to divide both sides by 3 to get rid of that times by 3 there. So x equals 2, otherwise known as the star equals 2. And we're drawing a rectangular prism on isometric grid. Now, isometric grid is pretty much just triangular dotty paper. It allows you to draw these types of shapes relatively simply, right? Which pair of points should she join with a line? All right, so what she's trying to do is a rectangular prism. And what we're trying to say is, right, so we know that this line here must have a parallel line, because it's a rectangle, and rectangles have to be parallel. So because we've got 1, 2, 3, 4 dots, 1, 2, 3, 4 dots. Now I've just happened to choose the right one, yes, but that's not an option. All right, so what I'm saying there is that's no good to me, because I've got to have 2 points joined together. What other points have got to join together? Well, we've got 1, 2, 3 dots from there, so 1, 2, 3 dots from there. Well, that's not connecting to anything. Obviously, I'd have to have a point joining to that. That's not connecting anything. But hold on a moment, we know that that's got to have sort of 4 dots end to end. There's 4 dots end to end. So I'm looking for these two there will join together to create my rectangular prism. So was it Q and U? And again, if I was going to finish this shape off, it would look something like that. And that's the ideal, that's a great thing about isometric paper, because it actually lets you draw these things. Question number 10, what is the best estimate for the capacity of this mug? All right, so 3 litres, is a lot. As far as I'm going to turn around and say 3 litres is basically like, if you imagine like a 3-pinter, would you think that that's going to fit in that mug? Nope, so that's a rubbish answer. 90 millilitres, 900 millilitres, right. So we know that there are 1,000 millilitres is equal to 1 litre, right? So this is roughly short of 1 litre. And again, trying to put a litre into that cup, not going to happen. 0.3 litres, right? So that's about a third of a bottle of milk, or a third of a litre of bottle of milk. And 90 millilitres is really, really tiny. 90 millilitres is not a lot of fluid at all. So I would suggest that my guess here would be 0.3 litres. Notice these are interesting questions because they're mathematical, but it's more about your reasoning for mathematics, okay? Not necessarily formulas or algebra or so much of that. Which of the following stories best fits the graph above? Now, when you have a distance time graph, you have to understand what each of these sections stand for in a distance time graph. And I know that when I've got a horizontal line, it means I'm stationary. I'm not moving, all right? I've not gone any more distance. I've not got any less. What we then notice here is that this line here is basically moving away. So I'm starting at 0 time and I'm going to somewhere. I'm effectively stopping, and then this means I'm just coming back. All right, so which of the following best? Melanie drove northeast, did some shopping and drove back home. Okay, maybe she's gone somewhere. She's done some shopping and driven back home. Melanie walked uphill, had a rest and ran downhill. Okay, interesting. Now, if she was to run downhill, then she'd actually take less time than she did going up, which means that we'd be looking here at a steeper gradient. Right, so it's not going to be this, because if she ran downhill, she's not going to have that gradient. Now, effectively, if we look at this line here, that means she's gone up at one speed, but she's come down slower. So the measure of gradient is quite important. Melanie ran to the park, rested for a while, and then walked home. That's possible because she's done something quite quickly, and she's come back slowly. Melanie walked to the beach, had a swim, and then ran back home. Well, again, she can't run back home because this here, because it has a shallower gradient, basically means she's done something slowly. So Melanie drove northeast, did some shopping and drove back home. To be honest with you, because the question says best fits, while the first one could, I would say this one here, because it talks about the idea of sort of a measure of speed. She's run and then she's walked, which explains the difference in the gradient. Which of these properties makes PQRS a trapezium? Line PS is perpendicular to line PQ. So PS is perpendicular to PQ. Well, that's not true of a trapezium. If you remember a trapezium, basically the best describer is that there are 2 sets of parallel lines. Yes, 4 sides, but 2 sets of parallel lines. So PS is perpendicular, I don't really care. QR is parallel to SR. So let's have a look. QR is parallel to SR. Well, it isn't parallel in any way, shape or form, because when it's parallel, they're never ever going to meet, and they very definitely meet. Line PR is perpendicular to SQ. So what is it? PR is perpendicular to line SQ. Well, doesn't seem to make any sense to me. I think that's just rubbish and thrown in there. And then line PQ is parallel to line SR. Well, there we go. As I said there, when we have 2 parallel lines and 4 sides, it is a trapezium. So again, that one there would be the one that I would choose. Oh, lovely. We're back to some algebra. Which expression is equal to that? Well, this is where we're going to collect like terms. So 5x minus 2 plus 3x plus 6. All right, so collecting like terms, we're going to collect my x terms together first. So 5x plus 3x is 8x. Then I have to be very careful. Minus 2 plus 6. We've got minus 2 plus 6, which gives me plus 4. So we're looking for 8x plus 4. Ka-ching. There is my answer. Ben and Lee were playing a game. They both started with 0 points. Ben's final score was 240. Lee's final score was negative 60. By how many more points did Ben have than Lee? Now, again, this is a trick. We've got 240, imagining a number line. We've got 0, and we've got Lee all the way down here at negative 60. Now, lots of people will add these together, and get 180, that's not the right answer. Because what we know is there are 240 points between 240 and 0, and there's these additional 60 points. So the total distance between those, you actually would add them together to give 300 points. Positive 300. Ben's final score was 240. How many more points did Ben have than Lee? So let's just check. Ben was here and Lee was down here. Yeah, so I didn't want to get tricked with that minus 300. Sanjeet puts two identical posters on his wall as shown. What is the distance D of the edge of each poster to the middle of the wall? Okay, so how are we going to do this? Well, we know the total length is 7 meters. So if we could find the length of one wall, that would be good. Well, obviously, because it's in the middle of the wall, we now know that this distance here is 3.5 meters. Why is that important? Well, we now know that this distance here is 1.5 because they've given me it here. We know this little distance here is 0.75. So that means that this final distance here must be the 3.5 minus 1.5 plus 0.75. Now again, this is a non-calculator paper, so you've got to be able to add these type of things together. So that's going to give me 3.5 minus, well, 1.5 plus that is going to give me 2.25. And then when I subtract that, it's going to give me 1.25 meters. So is there a 1.25? There is, and ka-ching, there we are. Stuart made a phone call that lasted 59 minutes. The cost per minute of the phone call was 89 cents. Stuart estimated the total cost of the phone bill to be about 54. Stuart's estimate was, well, first things first, let's see. 59 minutes at 89 cents per minute. Well, I'm going to round that to 60 times 90. So what we've done is we've rounded this one up and we've rounded that one up. Now, obviously, when I do 60 times 90, I get $54. I actually get in that situation cents because I did it in 89 cents. This would be in cents, but I know I can turn that into dollars. So he's got the $54 effectively by rounding the 59 up and the 89 up. And when you round both of them up, you're going to get what we call an overestimate. I see, okay? So this value here is going to be higher than his actual call, right? So in this situation, it's more than his actual call. If we'd rounded one up and one down, then it would be approximately equal to the call because we've sort of met it in the middle. If we rounded both of them down, for example, then our estimate would be less. So that's a little bit of learning there for you as well when you estimate. Which of these is the closest to 0? Whew. Now again, I tend to put all of these to have the same number of decimal places. It just makes life a little bit easier for me. So let's put a 0 there, 2 zeros there, and that's it. So now we've got 0.001, 0.10. So this isn't necessarily that helpful to read. 0, 0. So which of those is closest to 0? As it turns out, looking at these again, it would appear that this one here is the one that's closest to 0. And that's strange trying to tell you or work out how to explain the best way for that to be true. Obviously, the more zeros it has after the decimal, the smaller and smaller it gets. All right, so I suppose that's probably the best I can do here to explain it. Rani draws and labels 3 points as shown below. She wants to add another point so that all 4 points can be joined to make a parallelogram. Which of these is a possible coordinate for the 4th point? Now again, funnily enough, this type of question comes up at VCE quite a lot. Now a parallelogram, two sets of parallel sides. We could draw it in two ways. We could draw it like that. That's certainly one way. So if we were to do that, we know that the distance between these 2 points, it goes from 1. Yeah, so we know that our horizontal coordinate goes from 1 to 4. So I've gone 3 coordinates along. So if I now sort of rub that bit out and I add 3 onto this and go 1, 2, 3, which gives me that point there. And so 5, 1 could be a possible point. But what do you notice? It isn't actually there. And again, that's because this is a bit of a trick, because it's a perceptual thing. You've got to be able to say, well, is there another way I could draw a parallelogram? Well, actually there is, and it is this way. Now again, this distance here still has to be 3. So I'm going to go 1, 2, 3. That's where the point's actually going to be, which is at -1, 1. Is that one of my suggestions? It is, -1, 1. And so that's my point there. Now again, just to try and explain how I did that, when you're drawing a parallelogram, the distance between those 2 points has got to be the same as the distance between those 2 points there. This point here, how did I know the distance? Well, this had a coordinate of 1, 3. The other one had a coordinate of 4, 3. This value here is the horizontal distance, so it goes from 1 to 4. So how many is it moved? It's moved 3, which means that this distance here also has to be 3 spaces. So starting there, 1, 2, 3, it puts me at that point there, which is -1, 1. Nick works in a factory packing chocolate into boxes. He packs 1 box at a time. Each box contains 5 milk, 3 dark and 2 white. Every hour, Nick packs a total of 300 chocolates. How many dark chocolates does he pack every hour? All right, so he does this in total. So basically this is a ratio. We've got 5 to 3 to 2 with milk, dark and white. Now when we add those ratios together, every time he packs one of these boxes, then he's doing 5, 6, 7, 8, 9, 10. There are 10 chocolates in total. Now because he's done 300 chocolates, we then want to do 300 divided by 10, because that's going to tell me how many boxes he's done, yeah? Because he's done 300 chocolates in total. There's 10 chocolates in each box, and so he is going to have done that 30 times, which now means I can multiply each of these by 30. Because that's how many chocolates have going to gone in 30 boxes. So that's going to give me 150, 90, and 60. Now the good thing is when I add those together, and this is always a test, when you add those together, what do you get? Well, hopefully you should get 300, which we do. And so now how many dark chocolates does he pack? We're looking for dark chocolates, which is the one in the middle, which is 90. A standard 6-sided die is rolled once. What is the probability that the number on the top face is a factor of 6? So again, when we're throwing a die, and it's interesting they've called it a dice, because there are 6 sides, there is a 1 in 6 probability for any one of those sides, right? Because there's one side it's going to land on or show out of 6 possible. Now, because it wants a factor of 6, it wants to know what numbers divide into 6. Well, 1, 2, 3, and 6 are all factors of 6. So basically, there are 4 possible sides. If each of those sides is 1/6, I'm going to multiply it by 4, which gives me 4/6. Can we see that as an answer? No. Eesh. And that's because we know that we can cancel this fraction down. So that can be divided by 2, which gives me 2. That can be divided by 2, which gives me 3. And so 2/3 is my correct answer. Simplify this. Okie dokie. Now you can do this in lots of different ways. I tend to do this by cancelling out. Now that's this top one here is the same as 2 times 2 times 2 times 5 times 5 times 3 times 3 times 3 times 3 divided by, and the bottom one becomes 3 times 3 times 3 times 3. Remember, 3 to the floaty 3 is 3 times 3 times 3. I've got the 5, so that's just times by 5. And I've got 2 times 2. Now, the reason we're doing this is when we do this type of stuff, if all the top numbers are multiplied together and all the bottom numbers are multiplied together, we can effectively what we call cancel these out. So when a number appears on the top and the bottom, it cancels each other out. It actually becomes a 1, believe it or not. So a 3 on the top there, sorry, on the bottom there, cancels with the 3 on there, and they each become 1s. 3 there becomes a 1, 3 there becomes a 1, 3 on the bottom matches with that 3 on the top there, 3 on the bottom there matches with that 3 on the bottom there. Now what you notice is, because that all becomes 1 times 1 times 1 times 1, it effectively disappears. Can you see any other numbers that factor? Yep, a 5 on the top there cancels with a 5 on the bottom. A 2 on the bottom there cancels with the 2 on the top there, and a 2 on the bottom there cancels with the 2 on the top there. So what do we notice? Well, actually, all of our bottom numbers have now become 1. So 1 times 1 times 1 times 1 times 1 times 1 times 1 actually just becomes 1. So my final fraction is actually going to be over 1. What have I got left in the top? Well, I've got 2 and a 5, and that's it. It's literally 2 times 5. 2 times 5 is 10, and 10 on 1 is 10, so my correct answer there would be 10. Sandra is using a computer program to draw shapes. The picture shows 3 commands and the resulting shapes. Ellipse, ellipse, ellipse. Which shape would be drawn by this command ellipse 1, 4, 60? That's a very good question. So this is now a lateral thinking question. 3, 4. So obviously this 3 here is a reference to how wide it is. That 4 is a reference to how high it is. And I think this down there is the angle it's going to turn. So because we've got this number smaller than that, we know that the width, so the height, is going to be bigger than the width. So I already know that my ellipse is going to look something like this, but we're now going to have to make sure that we look at this 60. All right? So when it turns through 60 degrees, we've got to work out which way it's turned. Does it turn clockwise or anti-clockwise? As it turns out, it appears this is a turn anti-clockwise. Yeah, and you're just going to have to sort of work out or look at it and think about it. So 60 degrees anti-clockwise is going to move it that way. So it's going to, there's only one shape it can be, and I think it's going to be that one there. It takes 5 hours for 4 people to deliver leaflets to 1,000 homes. At the same rate, how many hours should it take for 5 people to deliver leaflets to 1,500 homes? I'm going to be honest with you, I hate these questions. Actually, let's think about it now. We've got 4 people to 5 hours to, right, so we've got, so 1,000 homes divided by 5 hours means they did 200 homes per hour. So it was 200 homes per hour, right? Because we had 1,000 homes, it took us 5 hours. 1,000 divided by 5 is 200, right? At the same rate, how many hours should it take for 5 people to deliver leaflets, right? So I suppose the question is, if there were 200 per hour and 4 people were delivering them, I'm going to divide that by 4, which gives me each person does 50 per hour. So each person does 50 per hour. At the same rate, how many hours should it take 5 people to deliver leaflets to 1,500 homes? Okay, so 50 per person per hour. So we've got 1,500 homes. Divide that by 5 people is going to give me 300. So that's 300 leaflets per person. And because they can each do 50 in an hour, we're going to divide that by 50. And 300 divided by 50 gives me 6 hours, right? 6 hours. Now again, I hate these questions. Tilly made a number pattern using this rule. Next number is previous number times square minus triangle. Square and triangle are whole numbers. Good. Her number pattern is this. What is the next number in Tilly's pattern? Using these two numbers here, her next number was 1 is equal to 2 times square minus triangle. And to get the next two numbers, right, so we've done a sort of a relationship between those two numbers. What about these two numbers? Well, her next number is -1 is equal to the previous number is 1 times square minus triangle. Okay, so what can we do here? Well, using algebra, we can actually work out what a square is. So what we now know here, looking at this, is that we know that we're going to add a triangle to both sides. So we know that -1 plus a triangle is equal to a square. So using this example here, we're going to substitute. We know that 1 is equal to 2 times square minus a triangle. Well, we know that a square is now the same as -1 plus a triangle. So it becomes 1 is equal to 2 times -1 plus a triangle minus a triangle. So that's going to become, we're going to multiply that out to become -2 plus 2 triangles minus a triangle. Add 2 to both sides is going to give me 3. And 2 triangles minus a triangle gives me a triangle. So a triangle is 3. Right? And in which case, because a square is equal to -1 plus a triangle, -1 plus 3, a square is going to give me 2. So that means we're going to times by 2, and we're going to subtract 3 to get to the next number. So let's look at this. So -13. So we're going to do -13 times 2 minus 3 is -26. Minus 3 is -29. That's my answer there. In a group of year 9 students, the ratio of boys to girls is 9 to 7. So 9 to 7 boys to girls. There are 4 more boys than girls in this group. How many students are in this group altogether? Okay, so if there's 4 more boys than girls, the first thing we need to know is that there's 16 students in total. So if I now double this and say, well, let's test what happens if there's 32 students, that must mean there are 18 boys and 14 girls. See what happens there? All I've done is I've said, well, I'm going to multiply each of those by 2 to see what would happen to my next ratio up. And that gives me 18 boys and 14 girls. Well, because it now says there's 4 more boys than girls in the group, are there 4 more boys? Yep, because there's 18 boys and 14 girls. How many students are in this group altogether? The answer must be 32. What is the value of x? I love this type of stuff, and basically there's lots and lots of different ways of doing it, but ultimately we want to try and get rid of that divide by 2. So x on 2 is equal to 3 on 11 times both sides by 2, which means that that disappears, gives me x is equal to, well, when we times by 2, that's the same as timesing by 2 on 1. And then when we multiply fractions, what do? We multiply the top 2 numbers together and we multiply the bottom 2 numbers together. And so what do we get? 3 times 2 is 6, 1 times 11 is 11, so x is 6 on 11. A rectangular hexagon has a perimeter of 12 centimeters. It is then cut in half. What is the perimeter of each half of the hexagon? Now this is a huge trick, okay? Now basically, when you cut it in half, you're now actually going to have a perimeter including this line here, and a lot of people will miss that. All they'll do is add together these 3 sides there without realizing you've actually added a side by cutting it in half. So what do we know? A regular hexagon has a perimeter of 12 centimeters, so we know that all of these add up to 12. There are 6 sides, so 12 divided by 6 will tell me that each side is 2. 2, 2, 2, 2, 2, and 2. 2, 4, 6, 8, 10, 12, right. So that means that that's 2, and that's 2. Now again, another thing you need to know about a hexagon is that actually this distance across the way is actually twice the distance from side to side. So that's also now 4, which means that when we add the perimeter, what is the perimeter each half? 4, 5, 6, 7, 8, 9, 10. The answer actually comes to 10 centimeters. Lena drew a line with equation y is equal to 3 minus x. Now obviously if you got me in maths, we're literally just doing this. She then drew another line on the same grid with the equation y is equal to x minus 1. What are the coordinates of the intersection point? Now again, we haven't quite done this. When a line intersects, we know the y values are exactly the same. So what I want to say to you is this. I'm going to write the equations again, but underneath each other. Y is equal to 3 minus x, and y is equal to x minus 1. If we know that these 2 things are the same, then it must go that these 2 must be the same. That's what an equal sign is. Right? So not only do I have an equal sign here. So now that tells me that 3 minus x is the same as x minus 1. What do? Well, let's get the x's on the same side. So I'm going to add x to both sides. That's going to get rid of this. Add an x to that side gives me 2x. What am I then going to do? I'm going to get rid of the minus 1 there by adding 1 to both sides. So adding 1 to both sides gets rid of that. 3 plus 1 becomes 4. 4 equals 2x. So x must be equal to 2. Now again, that's not the end of this because we need to find coordinates. And a coordinate is a relationship between an x and a y value. Is there a way of me finding a y value given an x value? I should COCO, because that's what that equation there says. Y is equal to x minus 1. We know that x is 2 minus 1, so y becomes equal to 1. So my coordinate, because we always write them as x comma y, is 2 comma 1, which gives me that answer there. A few more questions left, guys. A square pool for small children has sides which are 3 meters long. 1 cubic meter can hold 1,000 liters of water. So they're telling you 1 meter cubed is equal to 1,000 liters of water. How many liters of water will fill the pool to a depth of 50 centimeters? Now again, they've highlighted this for you because they're trying to trick you. All right, so it's a square pool. So when we're trying to find the volume, we know it's the area of cross section. He says area of cross section times by the height. Now in this situation, the area of cross section is the bottom, right? So that's the area of that bit. So that's 3 times 3 meters, but we have to then come up by the height, and that's half a centimeter, which is actually 0.5 meters. So we're then going to have to multiply that by 0.5. Well, 3 times 3 is 9 times 0.5. Now, when you're timesing by 0.5, you're actually saying a half of. That's exactly the same as saying a half of 9, which is 4.5. So that's 4.5 meters cubed, but you'll notice it wants it in liters. So every single meter cubed is 1,000 liters, which means I'm going to times that by 1,000. Again, you don't need a calculator for this. When you multiply by 1,000, you move the decimal point 3 places to the right. So I've got 4.5, 1, 2, 3. Fill in the zeros there, gives me 4,500 liters. The area of a rectangle is 600 millimeters squared. I'm going to draw a rectangle, and inside there I'm going to do, 60 millimeters squared. The side lengths are doubled to make a new rectangle. All right, so what we're going to now do is we're going to double the length there and double the length there. The area of the new rectangle is, now when you double both sides, you take the area and you double it twice as well, because my area is going to grow twice as big that way and it's going to grow twice as big that way, which is why we take the area and times it by each of those scale factors, because we're doubling it and then doubling it again. So 60 times 2 is 120, times that by 2 gives me 240. My units are millimeters squared, and so 240 millimeters squared. Holly created a shape using various regular polygons. A regular polygon is basically a shape with equal side lengths. She began by using a triangle with a side length of 1. Okay, she then added regular polygons, each with one more side than the previous one. Okay, she continued this way until a 10-sided polygon is added to a shape, or with the perimeter of the whole shape. Okay, so they're looking for you to create a pattern. In this situation, what is the perimeter? Well, if we know that each side is 1 by 1, that's going to have a perimeter of 3. This is going to have a perimeter of 1, 2, 3, 4, 5. This is going to have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8. This is going to have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got the patterns. So the first shape, second shape, third shape, fourth shape. And let's look at the perimeter. 3, 5, 8, and 12. Is there a pattern? So how much does that go up by? That goes up by 2. That goes up by 3. That goes up by 4. And so what can I do now? Well, I can just say, well, okay, we've got 5, 6, 7, 8, 9, and we want the 10th shape. So we're going to add 4, 5 onto this is going to give 17. Then we're going to add 6 on to give me 23, add 7 on to give me 30, add 8 on, 38, add 9 on, 47, and add 10 on is going to be 57. Let's just check that. 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the perimeter of the whole shape will be 57 centimeters, right? So again, this was just knowing a little bit about perimeter. And the last question is, Kumi is 3/4 the height of Zach. Sue is 2/3 the height of Zach. Kumi is 15 centimeters taller than Sue. How tall is Zach? So here's Zach. Here is Kumi. And here is Sue. So he's X. He's 3/4 of X. If we take X as the height of Zach, and they're 2/3 of X, and we know that if we were to do this value here minus 15, we'll get this one here. Okay, so in which case, because we know there's a height difference between the two of them of 15 centimeters, I know that, now who is the tallest? Which is biggest? Kumi or Sue? Well, as it turns out, it's Kumi. So we know that 3/4 of Zach's height minus 2/3 of Zach's height must be equal to 15 centimeters, right? Because we know the difference between those two heights is 15 centimeters. Now, how are we going to do this? Lots of different ways of doing it. I tend to get rid of the fractions first, so I don't like this divide by 4. I'm going to times absolutely everything by 4 first. So that gives us, that disappears, which leaves us 3x. When I times by 4, I times the top number only by 4. That gives me 8x on 3 is equal to 15 times 4 gives me 30, gives me 60. I don't like this divide by 3, so what I'm now going to do is times everything by 3. That gets rid of that, so 3x times 3 is 9x, minus 8x is equal to 6, 12, 180. 9x minus 8x is x is equal to 180. So Zach is 180 centimeters, which again sort of makes sense because if I ended up with, I don't know, 500 centimeters, Zach would be a freak of nature. All right, there we go, ladies and gentlemen. That's the end of this non-calculator. That was actually quite tricky. Some of it was interpretation, some of it was just sort of guesswork, some of it was just knowing, oh, obviously maths, but hopefully this video has helped. I'll see you in another NAPLAN video. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.